Hi everyone, this is Mr. Campagna. Today we're going to be talking about calculating the half-life of a radioactive isotope. So let's jump right into the independent work. Here is a reaction showing the fusion of a hydrogen-2 atom and a hydrogen-3 atom. The disintegration of unstable nuclei does not occur all at once. The rate of disintegration is a statistical process. The most convenient way to consider it is by a concept known as half-life. The time required for half of the atoms of any given quantity of a radioactive substance to decay is the half-life of that element. Each particular isotope has its own half-life. For example, the half-life of radium-226 is 1,600 years. That is, beginning with the 1.00 gram of radium-226, it would take 1,600 years for half of it to decay and leave 0.50 gram remaining. After another 1,600 years, only 0.25 grams would remain. In each half-life, exactly half of the beginning amount decays. This is why it's referred to as half-life. So try solving this on your own. I'll go step by step with you, you'll see at the end. It says here half-life of various substances. You've got hydrogen, carbon, polonium, uranium. You have their atomic symbols and some information about them. And you also have their half-lives. Example, 4.00 grams of tritium, which is also known as hydrogen-3, are produced in the lab. How much of it will remain after 24.6 years? Okay, well, I like to do this by creating a table. So on the left, I have the elapsed time. In the middle, I have the amount of the parent element. And on the right, I have the half-life number. So how many half-lives have elapsed? Now, you can see here that our elapsed time is 0. We're starting off with 4.00 grams. You'll notice that it's hydrogen-3. It's tritium. And hydrogen-3 has a half-life of 12.3 years. So how do you do this? It says elapsed time. We're starting off at 0 and 1 half-life passed by. So this column will have the number increased by the half-life of the isotope. So in this case, it's going to go up by 12.3. Next, to get the amount of parent element, we're going to divide by 2. So 4.00 divided by 2 is 2.00. And then the half-life, we're going to increment that up by 1. So after 1 half-life, 12.3 years have elapsed, and the amount of the parent element went from 4.00 grams down to 2.00 grams. Now we're just going to follow that pattern for the next one. So how much time has elapsed? Well, another 12.3 years, which will bring us to 24.6 years. The amount of parent element that remains will again be divided by 2. So we're going from 2.00 grams down to 1.00 grams. And our half-life will increment up by 1. So by our second half-life, 24.6 years have elapsed and 1.00 grams of the parent element remain. So again, it was 24.6 years we were looking for, and you'll notice we hit that. So our final answer is 1.00 grams will remain. Now, you don't have to do this as a table each time. I do find it easier for organization, but it does take more time to write it out that way. So here, example solved. 24.6 years is 2 half-lives for hydrogen-3, so 1/4 of the original amount will remain. That would be 1.00 grams. So again, it was 24.6 divided by 12.3. Again, that's the total amount of years divided by the half-life gives us the number of half-lives. So here it would be 2 half-lives. So we just have to go through this process twice. 4.00 grams divided by 2 equals 2.00 grams. 2.00 grams divided by 2 equals 1.00 grams. All right, I'd like you to take a moment and go over this check for understanding. So determining the amount of radioactive isotope left over from a decaying element over a certain amount of time really isn't that difficult. Just remember, you're going to be increasing the elapsed time by the half-life. you're going to be dividing the amount of the parent element by 2, and you'll be increasing the half-life number by 1. And really, you could just keep following this pattern as long as it takes for you to get down to either the amount of remaining parent element that you're looking for, or for the number of half-lives that you're looking for. So I hope this was helpful. Thanks for watching.